Pluto, the confusing little planet residing at the outer extents of our close-by planet bunch, is stirring up energy inside the vast local area. Continuous reports show a likely experience with Neptune, raising worries among scientists and space fans the same. Lofty experts, including Neil deGrasse Tyson and Michio Kaku, have sounded cautions about the reasonable aftereffects of this heavenly struggle. But how did Pluto end up on an effect course with its distant neighbor, and how might this boundless accident affect us here on Earth? Let us examine this unfurling occasion. Once remembered to be an obvious planet, Pluto was thusly renamed as a Pee-wee planet because of its remarkable circle. No matter what this change, it proceeds to end delight and draw in space specialists. Continuous expectations from conspicuous specialists feature a focusing on proximity between Pluto's circle and that of Neptune. These experts caution against the potential effect between the two planets, representing a huge danger to Earth. Pluto's excursion around the Sun is set apart by its prevalent qualities inside our close-by planet bunch. Its circle traverses a noteworthy 248 years, and since its disclosure in 1930, Pluto actually hasn't finished a full transformation, adding to its interest. The outstandingly round state of its circle is a takeoff from the almost round circles of the significant planets. Besides, Pluto's circle is shifted at 17 degrees to the ecliptic plane, making its way more extreme contrasted with different planets. One unmistakable element of Pluto's circle is its convergence with Neptune's way. For around 20 years in each circle, Pluto adventures nearer to the Sun than Neptune, opposing assumptions in light of their overall situations in the planetary group. So why hasn't an effect happened among Pluto and Neptune? The clarification lies in the gravitational powers applied by different planets. The examination of Pluto's circle started soon after its disclosure, introducing a surprising test for cosmologists. Dissimilar to most planets whose circles adjust moderately near the ecliptic plane, Pluto's one-of-a-kind highlights incorporate a precarious tendency and a flighty circle. The secret developed with the acknowledgement that Pluto's circle crosses that of Neptune. The dependability of Pluto's circle, in the midst of these intricacies, fills in as proof of the complexities innate in space mechanics. The three-body issue in space includes working out the movement and gravitational cooperations among three heavenly bodies, for example, Pluto, Neptune, and the Sun. This issue makes sense of the mind-boggling trade of their ways and gravitational powers. Terms like libration and the Kozai effect assist with disentangling this heavenly secret. Astrophysicists contend that libration, answerable for keeping up with planets in their circles, assumes a key part in the Pluto-Neptune framework. This term implies that when Pluto crosses Neptune's circle, it is arranged something like 90 degrees away from Neptune, essentially forestalling potential accidents. Libration guarantees that when Pluto approaches Neptune or other Goliath planets, it is organized dominatingly over their orbital plane, offering an additional layer of security against influences. The Kozai effect makes sense of why Pluto's circle around the Sun seems sporadic, yet stays stable over the long run. In spite of apparent haphazardness in space, numerical reenactments in the last part of the 1980s uncovered that, in spite of its consistent properties, Pluto's circle is truly tumultuous, with slight beginning deviations prompting tremendous changes more than great many years. However, Pluto's exceptional circle keeps up with steadiness throughout staggeringly significant time frame scales, keeping jumble inside limits. Progressing PC tests have improved how we might interpret what huge planets like Neptune, Jupiter, and Saturn mean for Pluto's way around the Sun. Neptune's extraordinary relationship with Pluto, finishing 3 circles for each 2 of Pluto, adds to the strength of Pluto's circle. Also, Jupiter's monstrous gravity applies a significant impact, while Saturn's impact, however more modest, likewise assumes a part. Through broad examinations, scientists have shown that the consolidated impacts of Neptune, Jupiter, and Saturn guarantee the protected and stable development of Pluto in space for billions of years. These peculiarities are critical for keeping the control and consistency of divine developments in the universe. Without these components, the nearby planet group would be inclined to more noteworthy disarray, possibly prompting impacts or discharges from stable circles and causing far-reaching ramifications for other divine bodies. Understanding Pluto's circle is especially significant in discussions about a potential accident with Neptune later on. This information offers a more clear comprehension of the unique idea of the planetary framework. Pluto's case features the way in which apparently temperamental circles can arrive at harmony through the perplexing collaboration of gravitational powers and orbital mechanics. Continuous observation and analysis of these phenomena are imperative for gaining a better understanding of our place in the universe. Investigating the depths of space frequently uncovers the impulsive nature of celestial bodies, and Pluto's circle serves as an ideal illustration of this whimsy. The concept of orbital instability strikingly demonstrates the sensitive dependence of a celestial body's path on its initial conditions. As illustrated in Pluto's case, even slight variations in the dwarf planet's position or speed can decisively modify its long-term orbit. Automatic simulations have been instrumental in assisting analysts with understanding how Pluto moves in space. By making small adjustments to these simulations, space specialists can observe how even minor changes can significantly affect Pluto's trajectory. In the late 1980s, these simulations uncovered a captivating aspect of Pluto's orbit. Despite factors like libration and the Kozai effect contributing to its stability, Pluto's orbit can still show irregularity. Even a tiny initial difference in Pluto's position or speed can lead to significant changes in its orbit over many years. However, despite this inherent disorder, Pluto's orbit remains stable over an incredibly long time scale, spanning billions of years. This suggests that beneath its seemingly erratic appearance, Pluto's journey around the Sun follows an organized order influenced by celestial events. Predicting the future paths of celestial bodies, especially with planets like Pluto that have unusual orbits, is extremely difficult. The intrinsic volatility of these systems makes long-term predictions uncertain. Numerical simulations help us understand and forecast the future motions of celestial bodies, but they also reveal the limits of our predictive capabilities. These models heavily depend on precise initial conditions and mimic complex interactions, where even a small error can lead to radically different outcomes, making accurate forecasts challenging. The turbulent nature of celestial orbits, such as Pluto's, reminds us of the ever-changing universe. While we've made progress in understanding space, Pluto's case highlights our ongoing limited knowledge. Understanding the gravitational effects of giant planets on Pluto's orbit provides valuable insights into the broader dynamics of the solar system. It shows how the presence and position of each planet can influence the stability and trajectory of other bodies in the system. Despite these complex forces, prominent astrophysicists are expressing concerns about a potential collision between Pluto and Neptune. Neil deGrasse Tyson, a renowned astrophysicist, offers a remarkable perspective on the mysteries of our solar system, especially in regard to Pluto. Tyson, famous for renaming Pluto as a dwarf planet rather than a true planet, shares insightful thoughts on how we might interpret celestial mechanics, which is constantly evolving. He views Pluto's renaming not as a demotion, but as a necessary adjustment in line with our growing knowledge about the various objects orbiting the Sun. His approach to celestial mechanics involves continual learning and adaptation. Tyson sees the complexities of orbits like Pluto's as an example of how much more there is to discover in space. Tyson believes that the allure of these mysteries is what makes astronomy so fascinating. Furthermore, Tyson is aware of how space-related events and discoveries capture the public's attention. He views events like Pluto's renaming and its unique orbit as opportunities to engage the public's imagination and curiosity. By examining the dynamic and sometimes chaotic aspects of space mechanics, Tyson fosters a deeper understanding and enthusiasm for the universe. Tyson opens a window for the general public to marvel at the wonders and mysteries of the universe, working alongside other experts. Tyson actively warns the public about the potential dangers of Pluto's irregular orbit, After extensive study of Pluto, he has raised concerns that the three-body problem could pose a serious threat, suggesting that a collision with Neptune might be long overdue. Additionally, Tyson stresses how such a collision could disrupt the balance of the universe and lead to disastrous outcomes, even extending to Earth. A collision between Pluto and Neptune would be a rare and catastrophic event in our solar system. This crash would release a vast amount of energy, probably destroying Pluto due to its smaller size and icy composition. Debris from the impact could spread throughout the solar system, posing potential threats to other planets and their moons. For Neptune, such an impact could potentially alter its atmosphere and orbit, depending on the specific details of the collision. Michio Kaku, a popular theoretical physicist known for his work in string theory and science communication, offers a fascinating perspective on this scenario. His views on the future of space exploration and the connection between celestial mechanics and theoretical physics provide profound insights into phenomena like Pluto's orbit. Kaku sees the study of Pluto and its orbit as a glimpse into the future of space exploration. Understanding the complex gravitational interactions between Pluto, Neptune, and other planets allows us to comprehend the long-term stability of the solar system and the potential risks that arise from these interactions. Kaku believes that the study of Pluto's orbit not only provides insights into the unique dynamics of our solar system, but also illuminates broader cosmic principles that apply to other systems in the universe. His expertise in theoretical physics helps contextualize the complex forces at play between Pluto, Neptune, and the other giant planets. Kaku suggests that, while the immediate threat of a collision may seem remote, the gravitational interactions between these distant planets could have far-reaching consequences, possibly extending beyond the solar system itself. This perspective is particularly important as we explore the future of space exploration and seek to understand the evolution of our cosmic neighborhood. The continued study of Pluto's unusual orbit helps us learn more about how smaller celestial bodies interact with larger ones and how their trajectories can be influenced by external forces over time. Kaku emphasizes that understanding these interactions is not only crucial for predicting the future of Pluto, but also for unraveling the mysteries of other distant celestial bodies that may share similar traits. As we look to the future, the possibility of discovering new dwarf planets or even reclassifying other objects within the solar system becomes more likely. With advancements in technology and a deeper understanding of the universe, scientists may uncover more about the complex gravitational relationships between planets, moons, and other objects in space. The study of Pluto, as a case in point, will likely remain a focal point of astronomical research, offering crucial lessons about the delicate balance of celestial mechanics. While the potential for a collision between Pluto and Neptune may remain unlikely in the near future, the understanding of how gravitational forces can maintain stability or cause instability offers a valuable lesson. It underscores the importance of continued research, careful observation, and the need for deeper collaboration among scientists in the fields of astrophysics, orbital mechanics, and space exploration. The ongoing study of Pluto also reminds us of the ever-changing nature of space. What we know today may evolve as new discoveries are made and new technologies allow us to peer deeper into the cosmos. It is a reminder that our understanding of the universe is not fixed, but continually shaped by the new data we gather. Each new discovery, no matter how small, adds to the grand puzzle of the cosmos, inviting us to explore further and push the boundaries of our knowledge. In conclusion, the potential collision between Pluto and Neptune is but one of many examples of how celestial mechanics continue to intrigue and challenge our understanding of the universe. While such an event may not be imminent, the careful observation of Pluto's unique orbit offers invaluable insights into the forces that shape our solar system. As we continue to study Pluto, we may unlock even more mysteries about the nature of space and the delicate balance that governs the movement of celestial bodies. And with the combined efforts of scientists like Tyson and Kaku, we are better equipped to understand the complexities of the universe and the ongoing journey of discovery.